Today's lesson is on proving triangles congruent by angle side angle or angle angle side. So we have already talked about that there's 6 parts to a triangle, 3 angles and 3 sides. But I don't need to name all 6 parts congruent to say I have 2 congruent triangles. I can do 3 parts, but they have to be in a specific order. One of those orders is called angle side angle. So that means I have 2 angles in the included side, which is the side between those 2 angles. So I'm looking for sides, tick marks or shared sides or equal numbers, and angles I'm looking for arc marks or vertical angles. Okay, let's do a proof. Okay, we want to prove these 2 triangles are congruent by angle side angle. So we've been writing proofs for a while, so I take the information that was given and put that in my statements. And the reasons for the things that are given is given. I am proving, this is what I'm doing. I don't ever write the word prove, and I'm trying to prove that my 2 triangles are congruent. So I write that as my last statement. Okay, the information that was given is segment AD is parallel to segment EC, and I see that with these arrows that are not on the ends. And segment BD is congruent to segment BC. This is given, so this is one of my sides. So the next thing I can say is, since these lines are parallel, then I can say this line here is the transversal cutting these. And I can say that angle C is congruent to angle D. And I can say that because those would be alternate interior angles are congruent. So angle C is congruent to angle D because I have parallel lines and alternate interior angles are congruent. So these 2 angles are congruent. So that would be an angle. And then I see that these are vertical angles right here. And I can't name it just angle B because there's 2 angle B's. So I need to use 3 letters. So I can call it angle ABD and angle CBE. And those are vertical angles. So now I have an angle, a side, and an angle. So I have the included side. I can see that either way in these 2 triangles. So when I have the order of side, angle, side, or I'm sorry, angle, I wrote side here. I'm sorry. So the order in the theorem is not the order. I want them in the order that I see them in the triangle. So in the triangle, they are angle, side, angle. So I can say these 2 triangles are congruent by angle, side, angle, triangle congruence. Okay, let's check. In the diagram here, I am told that AB is perpendicular to AD, segment AD. And DE, segment DE is perpendicular to segment AD. And segment AC is congruent to segment DC. So if I wanted to state that these 2 triangles are congruent, what would be my angle, side, and angle? So the side that's listed is the one that's given, is this segment AC is congruent to segment DC, and angle A is congruent to angle D. These are both right angles. So then my second pair of congruent angles are these vertical angles here. So I can list them. I can't list it as just angle C because I have more than one angle C there. So I can say angle ACB is congruent to angle DCE. Okay, so let's go to another type of triangle congruence. This type is called angle-angle side. So again, in order for me to prove my two triangles are congruent, I only need 3 parts. But I need them in the specific order where I have an angle, and then the non-included side. So this time I don't want the side between the angles. I want a side that is not between the angles. So let's do a theorem. Given that segment HF and GK are parallel, so I'm going to write that in statements, and my reason is given, and angle F and angle K are right angles. Those are statements again, and my reason is given, and I am proving, this is what I'm doing. I don't ever write that, and I want to prove my two triangles are congruent. So that's my last statement. Okay, so angle F and angle K are right angles. So I have some parallel lines. So since I have parallel lines, here's my transversal. I can say that angle FGH is congruent to angle KHG because of alternate interior angles if I have parallel lines. So this is one of my angles. So this is giving me a clue here. I have a right angle, so I can say angle F is congruent to angle K. This is another angle. And then I'm looking at my shared side right here. So I'm sharing this side. So this is the side that I'm going to use. So this is segment GH is congruent to segment GH. So this is my side. And I can say this is equal to each other because of the reflexive property of congruence. So in my triangle now I have an angle side. And in my second triangle I have an angle side. So the order is what, it doesn't matter what order I have it actually in the theorem, it's the order in the triangle. So since I have it in that order, I have angle side, triangle congruence. Okay, that's it.